A ray of light emerging from glass into air is refracted and bends away from the normal. Like in this case, I will be less than R because it travels from a denser medium to rarer medium. And here we notice that the ray which is normal to the surface is not bent, as we have already studied in the last lesson. Anyway, some of the rays reflected back as well. Now, if we go on increasing the angle of incidence, or as I is made bigger, the refracted ray gets closer and closer to the surface of the glass. When I is equal to C, the refracted ray is just touching the glass surface, and R will be equal to 90 degree, this one. And when a ray of light is incident from glass to air at an angle greater than the critical angle, then all of the light is reflected at the glass air boundary. It is called internal reflection because it occurs inside the glass, and is called total because all the light must be reflected. Now, total internal reflection has uses in prisms, optical fibers, etc. And I have just here give a clear picture of the critical angle, which is the angle of incidence for which angle of refraction is 90 degree, like in this case. An optical fiber consists of a very thin core of high purity glass. The core is covered by a second layer cladding, which is also made from high purity glass. The cladding is less dense than the core and has a lower refractive index. As for total internal reflection to occur, the light ray must travel from a denser medium to a less dense medium. Therefore, light rays passing along the core at an angle greater than the critical angle are totally internally reflected. Now, how do optical fibers work? When light from a laser enters at one end of the fiber, striking the surface of the glass at an angle greater than the critical angle, total internal reflections at the glass surface takes place and light cannot escape from it until it reaches the other end of the fiber. Now, visible light and infrared both can travel long distances in glass with very little being absorbed, and hence these both can be used. The plastic coating prevents scratches on the glass surface, which can allow the light to escape from the side of the fiber. Now, uses of optical fibers. Optical fibers carry enormous amount of information as pulses of light. Moreover, optical fibers are used extensively in the field of telecommunication. In telecommunication field, they are used as an alternative signal carrier to copper wires in the telephone system. They are used to carry digital signals in the form of light pulses over long distances. A periscope. The periscope is an instrument for observation. It consists of a tube with mirrors at each set parallel to each other at 45-degree angle, with the addition of two simple lenses, and it depends on the occurrence of regular light reflection on the plane mirrors. The periscopes are used to observe over the obstacles of between 9 and 26 meters in height. The periscope is used in the submarines to see what's going on the water surface. It was used for observation purposes in the trenches during World War I. Now, the periscope is used in the submarines to see the events which are happening behind a wall and a barrier, and some submarines use complex periscopes which make use of the prisms instead of lenses, or advanced fiber optics instead of mirrors to provide them the magnification. Complex periscopes operate on submarines in different fields of science.